Hey everyone, so this video isn't really mandatory. If you want to skip around, you can, but if not, I'm just going to quickly cover a few properties of a transpose of a matrix. It sometimes becomes useful if you can use these properties, but mainly use these properties if you're trying to make a use of some sort of a proof in linear algebra courses or something like that. But some of these properties are helpful if you're able to spot the patterns. So the first one is it's probably intuitive, but if you didn't know, let's say I have some matrix A. If I take the transpose of that, the rows become the columns and the columns become the rows. Now, if I take the transpose of that, then what do you think will happen? Well, I should be able to go right back to my original matrix, right? So, an example of this is if I have some matrix A, I'll call it 1, 2, 3, 3, 2, 1, and 2, 1, 3, right? Then A transpose would be what? Well, the first row becomes the first column, so 1, 2, 3. Second row becomes the second column, so 3, 2, 1. And then third row becomes the third column, so 2, 1, 3. Right? So now what's the transpose of this? So A transpose, right? That's the same thing as, just writing a T over here. And so what's the transpose of this now? Well, the first row becomes the first column, so 1, 3, 2. Second row becomes the second column, so 2, 2, 1. And then 3, 1, 3 becomes the third column, so 3, 1, 3. Did I get back to my original? Yeah. 1, 2, 3, 3, 2, 1, 2, 1, 3. So that's one of the most useful properties I would say of a transpose, but somewhat it's intuitive as well. The second property that and these aren't really ordered properties. I mean, you can just use Google to help you find a lot of them. But let's say you have some constant A, or well, some constant C, right? And you have some matrix A. And if you perform constant times A, right, you'll just be multiplying each element in the matrix A by the constant C. And then you take the transpose of the whole thing. This is the same thing as saying constant times A transpose. Okay? So basically, again, this is sort of intuitive. If you have a matrix A and you're multiplying it by C, so for example, let's just keep this matrix, and then instead of C, I have 2, right? If this is the case, then CA would be equal to 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and so forth. There will be 6, 4, 2, and then the next one will be 4, 2, 6. Right? If I take the transpose of this, that's the same thing as saying just take the transpose of the first matrix, A, without the constant multiplying, and then multiplied by the constant. Right? Third property is also somewhat helpful, and it's basically saying that if you have a matrix addition going on, addition or subtraction doesn't really matter. So if I have A plus or minus B, right, and then I'm taking the transpose of that, then that's the same thing as saying A transpose plus or minus B transpose. Okay, um, and yeah, I mean it's pretty self-explanatory. You're not gonna, you probably won't need it, but it's a good, helpful property to have. The other one is with multiplication. Sometimes this becomes really useful. Okay, um, so it's number 4. I'm just gonna label it number 4. Let's say you have some matrix A and you're multiplying it by another matrix B, right? And you're taking the transpose of the product. That is the same thing as saying switching up the order of multiplication. So it'll be B transpose times A transpose. Okay, this isn't the same thing as saying B A transpose. Okay, if you recall, we can't always even multiply the reverse order of matrices, and most of the times you won't even probably get the same answer. So AB is not the same thing as saying BA in the matrix world. So if you do this, then AB transpose is the same thing as saying B transpose times A transpose. Now, the other properties of transpose of a matrix have to do something with the determinant and the inverse. We haven't covered determinants or inverses yet, so I won't include it in this video. But when we do cover it, if I can remember, if it's important, I'll remember. But whenever we cover determinants and inverses, we'll go over the other transpose properties. So for now, that is it. Hope you liked it. I'll see you in the next one.